Yes, Yahira and John, click on example B. Everyone will hear. So find an algebraic expression that is equivalent to the expression sine arctan x. The first thing we talked about on the previous day's lesson is that I can make this to our favorite Greek letter.
Alpha.
How about theta? So basically the end result is this. I need to find sine of theta. That's what I need to do at the very end. Well, we have some puzzle pieces that kind of help us. I know that theta is equal to the arctangent of x. Class, if you're scared of the word arc, let's rewrite it now. Theta equals inverse of tangent of x. Okay, let's just keep doing what we've been doing. We know that this inverse tells us to do what, class? So let's switch them. What do I write? X equals tangent of theta. Okay, let's think about this. Tangent of an angle equals something. The something is positive. So I'm in quadrants 1 and 3. Okay, what's the easiest quadrant to work with? 1. So let's draw something in quadrant 1. And I'm drawing theta. So this should feel very familiar to yesterday's lesson, Friday's lesson. And when I think about it now, here's the hard part. Before we had worked with numbers, a fraction, a ratio, right? It tells us about its size. But I don't have anything. But I do have this x. How do you make this expression a fraction? Okay, we got something there. That's very important. Because tangent can be written how now? Tangent is equal to? Okay, that's one way, or opposite over the adjacent. So now I can go to theta and say the opposite side is equal to x, and the adjacent side is equal to 1. Well, I have two sides of a right triangle. I can use the Pythagorean theorem to solve for the third side of a right triangle. Class, what letter is this one? Okay. You guys are thinking back. That's fine. You can use X, Y, and R. I'm just going to use the A, B's, and C's, if that's okay. B and A. So here I'm just going to do my substitutions, and I'm just going to simplify. So I don't know this side. That's what I'm trying to solve for. My A value is equal to 1. My B value is equal to X. And now I'm just going to go through and simplify. C squared is equal to plus
X squared.
X squared. How do I remove an exponent? You're going to take the square root of both sides. Our answer is supposed to be a plus or minus square root of 1 plus x squared. Now, a reason why I'm only keeping the positive, because remember C here represents a side length. Side lengths are a distance, and distance should only be positive. So our C is equal to the square root of 1 plus x squared. So I have the opposite, I have the adjacent. This is the hypotenuse, this was the side we were just finding. And all I need to do now at the very end is I have all the sides of the triangle, and I just need to find sine, which is opposite over the hypotenuse. So I get x. Now I'm not going to write that in my box, and I'll tell you why. It's going to be x over 1 square root of 1 plus x squared. Everyone say no, no. You should not have a radical in the denominator. No, no. We have to rationalize it, so I'm just going to take this and write it again over itself, because that's an expression equal to 1. Zoom in over here. So if I multiply across here, I get x times 1 over x times square root of 1 plus x squared. And here, when you're multiplying, don't think expand, you just think you have two of these identical expressions. 1 plus x squared. I have two of those by multiplication. Well, the great news is the exponent and the radical cancel. So my answer is 1 times the square root of 1 plus x squared all over 1 plus x squared. Remember, do not be tempted to cancel anything here. You cannot cancel the x squareds because this is inside the radical and this is not. You cannot cancel this x and the x squared because these are called factors. There's multiplication here, and here you have addition. So don't be tempted to cancel there. And this is your answer. It's an algebraic expression given our clue of sine arctan x.